use to charge you interest. By the way, when you go buy a car, do not tell them you pay out of pocket, even though you have money, because they will never give you a good price. They make money by interest rates. So, I'll pay off later without them knowing, but don't tell them you pay it off even if you have money. Okay. Second, once you formulate the models, then you solve it using the appropriate method. And then after you solve it, now not everybody is math people. Face it, 90% of population is not math people, maybe more than that. So you have to interpret it with them. What does that mean? For example, in your exam, I asked you interpretation of the rates. What does that mean? If somebody does not know what you're writing, what does negative 20,000 mean? Well, it's appreciated value, negative 20,000 every year, right? And for the last bit, it had nothing to do with the first three. Is well, maybe it has something to do with the first three. Once you have the model, you test them, see how well they fit with the real world problem. Right? Business company do this a lot, right? Car company, they try to fit the model, see how well it actually worked for them, see how much money they make. If it's wrong, the worst thing they can do is go back to the beginning again, right? Formulate maybe another mathematical models, right? And that's all. Okay, so that's the gist of today section. So before that, let me introduce you behind the scene kind of things. Right? Polynomial functions. Can someone remind me or tell me at least one polynomial function that you know of? I know on your exam you have all three types, at least all three types of polynomial functions. Then give me one, yeah. The quadratic, right? The quadratic. So y equal ax squared plus bx plus c. And then the one before the quadratic is one power less than the square is the first power, which is linear, right? Linear. We rewrite linear as y equal mx plus b. And then the one before the linear is x squared, x to the first, x to the 0, which is 1, right? So if I write like this, y equal m times x to the 0 plus b, which is m plus b, which is some constant, right? Some arbitrary constant. That's why you have either a vertical line or horizontal line. Remember that? The constant function, not really helpful. I can't think of anything that we use it in real life, really. But we use the linear function a lot. Linear function is a lot because, first of all, it's simple. A lot of models follow linear function by nature. You plot the data point, they have that nice track of say gradually increase or gradually decrease. It's just the nature of the data, and it's easy to work with. Some models follow a quadratic function, and another one would be like exponential functions, whatnot. Now, this is the baby ways of writing your polynomial. The general way, what if I want degree 3, I want degree 4, 5, 6, etc. This is how you write it. You start with a constant, which is a sub naught. For example, in the quadratic case, would be c, it's your a naught. And then a1 times x, a1 to b, x, right? And then a2 x squared, or ax squared here, right? And then a3 x cubed, a4 x to the 4, etc. All the way to what? An x to the n. And the one before an x to the n is what? It's the one that 1 unit less than. So you just subtract 1, right? A n minus 1 times x to the 1. So it's just a general. I'm not going to ask you to memorize this. I never test you like definition and whatnot. Remember, n is a non-negative integer. So that means what? That means what? Your power should be the least power you have is 0, which is here. I don't write it, but it's active as 0, which is 1. So a constant times 1 is still a constant. Right? And active the first x squared. So n has to be non-negative integer. Right? Start with 0, 1, 2, 3, 4, 5, 6. We call A0, A1 to AN our coefficient. You probably already know this. Furthermore, all polynomial functions are defined for every value of x. What does this sentence mean in terms of domain? Yeah, it's defined everywhere, right? On that number line, everywhere. So if you grab a polynomial function, you run your pencil on it, it should be very smooth. No stopping, no gapping, no pointing, right? It's very smooth. All right. You guys take a few minutes to do this. In the meantime, I'm gonna look in some stuff. Your grades. So take a few minutes to do this, and then we'll talk about it later. Oh, thank you. Still recording. Yes. We have very good grade. Very good. I think the best grade I ever seen in all the classes I've been teaching for 5 years. Hopefully you keep it up. Keep it up. A lot of 90s, 80s. Depending on what I got, right? No, it's very good. It's really good. This is the practice test. It helped a lot. Yeah, and Lexi, you guys go to Lexi? Yeah, yeah. Maybe because that's why. This is my second time having SI. This at least she's in person. Before it was pandemic, so it was online. But yeah, stick to her. Yes, she's your savior. battery. All right, what you have? Number one, is it a polynomial? Yes, right, yes. Is all degrees are fine. The constant, by the way, the coefficient is real number. It doesn't have to be integer. It doesn't have to be 1, 2, 3. It can be any number, right? As long as it's real. Right? Number two. Yes, I'm missing second degree and first. I'm sorry. Yeah, I'm missing the fourth degree and second degree, but it's okay, right? If you're missing it, you can rewrite like this. You can rewrite like that. That's number 3. Sorry. And then what do I miss? I miss the second degree, so I just 0x squared, right? Plus 1/2 x, and I'm missing the constant, so it's just 0. Right? It's the same thing. Number 3. This is a polynomial. Why? Okay, good. You can graph it to see what happened, right? Now if you don't graph it, if you eyeball it, what happened to one of the x here? Yeah, square root. What degree for the square root? Yeah, highlight it. If I change it into to power, I can rewrite it x to the what power? The 1/2, right? X to the 1/2. Right? Index is 2. Maybe I'll use black. Index is 2, power is 1. One of my profs teach me how to do this. Imagine the little book here, you kick that 1 over. 1 over 2, right? Actually the first. So power over the index. 4. So nope. 4. Is it a polynomial? Yes, right. It's not the one that we're gonna learn today per se, because it's multivariable, but it is still polynomial. Number 5. Is it a polynomial? Careful, because well, the other yes. Because. All right. So okay, which one are we? Which one are you? Is itching you? Which one? This one, right? The x is in the bottom. Now if I change it to the top, remember here in the definition is it's all x on the top, right? See what happens if I change it to the top. 3/2 still 3/2. If I move it to the top and become what, x to the what power? Just did your exam, x to the what? If you switch the position of the x, the power is what? Change its size, right? So become x to the -1, right? And we agree that polynomial should have integer power, right? The least is 0, but it cannot have it. Well, I should say positive integer. So it's negative. So bad news. Nope. 6. Is it a polynomial? Okay. Who say yes? Just raise your hand. Just a guess. It's just a fun guess. Who say yes? Who say no? All right. It's not polynomial. Can someone tell me why? I'll give you 2 bonus check mark on your next exam. You can tell me why. Well, a 2 point extra. Yeah, 2 point. On the exam, not on the bonus check mark sheet. On the exam, like just 2 straight points. Motivation. Think harder. Why it is not a polynomial? It looks good. It looks really good, but it's not. Anyone? Give it a guess. Yes. Very good. Remind me, I forget. I think last time we gave somebody 2 points. I forget. All right. Yeah, because it's infinite. What do I say? Go back to the definition. Always go back to the definition. Is it infinite? No, it's not a some n number. It could be any, it could be 1,000, million, but it stops sometime, right? It stops sometime. Here is infinite. By the way, this is called a series, called power series. No, geometric series, I think. If you sum the ups, adding up, the sum is equal 1/1 minus x. I think it's a geometric series. I forgot. Yeah, I think so. Yeah, it's funny, huh? You add infinitely number of x, and you sum it up, and you get this. Cool. You learn it in calculus too. 7. You don't have this on your slide. You print it out. I try to add it later. Is 7 a polynomial? Why not? if you expand this out, it's going to be what, x squared plus 2x plus 1, right? And then you distribute, you have 4x cubed. Yes. That's What's your name though? No, the Katie. Did I last time did I tell you I give you 2 extra credits?
Oh, yeah. Like,
Katie. Okay, what's your last name? Somi. All right. I just remember to put in here. I'm doing it right now. Remind me, otherwise I'll forget. I didn't mean to. I want to keep my promise. I have a lot of things on my plate. All right. Story problem. I know it's not your favorite, but I promise these are easy one. Like really easy. Do you believe in global warming? I do. Just say yes to make me happy. Right? Yes, global warming. By the way, you cannot compare the weather from today or today to last week or today, even today from a day year before, and say that okay, Mimi, exactly today, last year, it was much cooler. Oh, well, it was much warmer, much colder today. So I don't think I believe in global warming. Wrong. Global warming is based on climate over time. Right? What you're telling me is weather. Right? You compare weather. Weather is what happening right now. Right? But climate is what happened over time, like thousands of years or hundreds of years. Right? And we see the trend. All right. The cause of global warming is carbon dioxide, right, based on what human produce, industrial, mostly. All right, the killing curve named after Charles David Killing. He found he gives the average amount measured in part per million volume in atmosphere from 1958 to 2013. Kind of out of date. All right, so here's your data. So in 1958, the amount of CO2 in the atmosphere is 315 part per million volume. So they say that they're gonna let T equal 1 at 1958. So 1970 T equal what? 70 minus 58 will be 12. So 12 plus 1 is 13. So 13 years later, right? And then 74 will be what? 4 more, so 17, etc. Right, etc. You calculate your T. You subtract it at 1. Okay. Now here is the function that we really care about is this one. It's that one. Question number 1, they want you to use the model, which is I highlight in red, to estimate the average amount of CO2 atmospheric in 1980. Well, easy, right? All you do is plug in 23 to the function. Now, on the exam, hypothetically, if I don't give you T, how do you find T? No, T is your X. T is here is your X. No, not grade. I'm not asking about slope. Actually, it's not a slope, right? It's a quadratic, so single slope. But thank you for input. If I don't give you t, how you figure out your t? So that's 12. That's 22. You add 1, right? Very good. You add 1 because you start t at what? 1, not 0, right? So you add 1. So you subtract and then you add 1. Just in case I don't give you the year. So now all you do is just plug it in. All right. I don't know about you, but I'm not doing it by hand. Decimals. Last Saturday, I attended a conference at Oakland Community College. Yeah, community college right here, Auburn Hill. It's one of the professors showing how to manipulate decimals to teach in his class. It's pretty cool. Yeah, he actually my mentor back then when I was undergrad. Oh, let me sign in. I make an account just for you. Where is it? I didn't save it, so it didn't save. Sorry. Last night I did it and I forgot to save. Wait, 12444 x square. And what was next? Wait, 7485 x plus 313.9. All right, you don't see it, so you have to oops, control. Zoom it in a little. Oh, I zoom it out. Zoom it in. Where is it? Oh, something wrong with my thing. What happened? Subscript cannot be empty. Oh, darn it. Huh? Control Z? No, it doesn't work like that. Darn it. Oh, man. Yeah. 0.012444 x squared plus 0.7845 x plus 313.9. Is something wrong? No, right there, right there. Yay. All right, and then you do a to the, I'm sorry, a of 23 is 338.5 part per million volume. So let's write that down. 338. How come I have a different value than the morning? Do I? I don't remember. PFV. Don't forget your unit. On the exam, one of the students wasn't this class, the other class. They put they did the rate very well, negative 20,000, which is I'm happy. But when they interpret it, it's saying every year if the depreciated value is negative 20,000. Negative 20,000 what? Dollar, yen. Give me some units, right? Yes. Oh, something wrong? 485. No wonder. I know the morning is not matching the morning. 485. Thank you. All right, better. I don't remember the exact answer, but I know that it's just a little off. 337.7. All right, you guys do number 2. Tell me what you got. comma. Sonia. Yeah. All right, you can see your grade now. You want to see? All right. What you have? What you guys have? It's lazy. I'm just doing that. What should I put for a what? 65. Very good, right? So you take 2022 minus 1958, and then don't forget to plus 1, right? So 65. And what's a sub 65? You can check your answer, your calculator. 415. Let me write down if I forgot. 415.1 ppmv. All right. So easy enough. Those are easy problem. Don't mess it up on the exam. You have one. Is there anything you want to ask me about this polynomial? Yes.
Yeah, I probably just did my math wrong. But I got 64 in my answer. What was I supposed to subtract 2022 from?
Oh, so I need to find t, right? To plug it in. So at 1958, t started at 1.
Yeah.
I want to do 2022. So 2022 minus 1958, which is 64.
Yeah, that's what I
But
got.
you had to add 1 because
All right.
you start at 1, you don't start at 0.
Yeah. Yeah,
When you
yeah.
subtract something, you start from 0. You add 1. That's why here we have a 13 instead of 12. All right. Rational and power function. You already see all of these on the exam. So rational function is just a polynomial over a polynomial, as long as the denominator polynomial is not equal to 1. Okay. So let me give you some example. Say I have r sub x equal x squared minus 1 over x plus 5. And the condition is x cannot be what? -5, right? So you have a polynomial over a polynomial. Another one could be like this. You want to be more complicated. X cubed plus x squared minus 5x plus 10 over x squared minus 6x plus 1 is still a rational expression, right? By the way, you cannot factor the top, the bottom. All right. Okay. Power function is a function of the form f of x equal x to the r. Now I didn't say now back, go back here. For the polynomial, I restrict the power of the x term has to positive integer or if it's 0, right? Well, I didn't say anything about x to the r. Right? R and x can be anything. It could be integer. It could be any real number, right? So x and r's are a real number. By the way, does anyone know that little funny e means? Script r is a set of real numbers, but what's the funny e? You see this a lot when you go to calculus and stuff. If you ever do calculus. It means belong to, right? It's inside a set. So x and r's is a set of real numbers. All right, so let me give you example. So say f of x equal square root of x. It is a power function because what can I rewrite this with? How do I rewrite this? The boot method, remember the boot method? First power and then index 2. I know square root, we don't ever write the square here, you know, like cube root, fold. But it's, there's a 2, invisible 2 there, right? So the boot method is that, it's getting cold now, people wear boot, right? You kick that one over, and now I have 1/2. The power is always on the top. The index is going to be in the bottom. You tell me, well, how do I use the boot method on this one? X to the what power? Yeah, 2/3, right? You kick the 2 over, so 2/3. That's how I remember it. Just easy to remember because sometimes you do 3/2, right? Just silly mistake. So figure out a way to remember things, even if it's silly. Or even doesn't have to be nice, neat, rational power. It can be something like really weird. X to the 0.0359, something like that. Right? It doesn't have to be nice and neat. Now, a lot of times you're going to see a combination of functions, like rational function and power function together. Let me give you an example. I can have something like that. Right? If you want to, you can rewrite it as what? X plus 1 to the what power? One half, right? Again, over x minus 1. Right? Or you can do it like this: f of x square root of square minus over x. Right? If you don't believe me, you can rewrite this to the what power over here, outside 1/2, right? Inside is x squared minus 1 over x. It's a same thing, it's just different way of writing it. We learned this in 62, when you remember. Okay, so that's math stuff. Let's by the way, don't memorize these. On the exam, I test you here, this part. Just introduce you all these polynomial, constant polynomial over a power function. Okay, driving cost. A study of driving cost based on a 2012 medium-sized sedan found the following average cost measured in cents per mile. So the cost is include everything: insurance, gas, upkeep, whatnot, and it measures cents per mile. So somebody drive 5,000 miles per year, it's cost that person 161.2 cents. So roughly per mile, right? $1.61 per mile. Right? Similarly, 10,000 miles per year, it's cost you 78 cents per mile. So that's what the table means. But what we want to really looking for is this one. So we can plug it in. Where x is measured in thousand. And x is the number of miles that they drive in each year. Using this model, estimate the average cost. So cost is the C function there. You want to find C. Per mile of driving a 2012 sedan medium size, 8,000 miles per year and 18,000 miles per year. Now, what do I plug in? Do I plug in 8,000 mile or 8? 8, right? Because X is measured in thousand. So we're gonna do I'm gonna do 8, right? So rewrite that 1910.5 over, oh, X is 8, write in black, 1.72 plus 42.9. 9, I say 9, I wrote 5. Sorry. Use your calculator. Nineteen 10.5 divided by X. 42.9. Yeah, 42.9. Let me mute this purple one. So right there. Oh, by the way, you know that this is no polynomial function. When you look at graph, it's not all real number, right? There's a little gap here, a little jump here. X cannot be 0, right? You go close to 0 from the left, and you skip 0, and you kind of get close to 0 from the right. Then you move forward. So you skip 0. You cannot have this to be 0. All right. C. C. A is 96. What's the unit? What's the unit? Cent. Cent. Let me write that down. 96.3 cents. And C of 18 is 56.1 cent. Yes. Oh, right here. They give it to you. The one highlight in red. Yeah. So far, so good. Just plug your number, really. Just be careful. That's all. For example, on the exam, maybe you put 8,000 instead of 8, stuff like that. Or up here, you may, forget to add that 1 to it. It's just a little mistake that you have to pay attention to. But in general, it's easy. Plug in. Done. All right. What time is it? Okay. Give a few minutes break. I'm gonna give you back your exam. We'll start the last one. I'm gonna put your name by last name first. Yeah, that's how they enter in Moodle. Adams, Jacob Adams, Adamus. Yeah. I think Nate. You. Dusan. Ashley B. Ashley. Taylor. Blake. Sam. Charles. Amaya. Gary. Connor. Haley. Eileen. Ella, Ella, David, David, Gabe, Ham, Jackie, Oma, Jackie here, Oma's here. Gina, Angelo, Antonio, Maddie, so, Caitlin, Sonia, Carlos, Jeff, no, oh Jeff. One of my favorite persons is Jeff. I like calling your name. Listen, not listen.
I think you said my name while I was in the bathroom.
What's your name?
Dusan.
Dusan, okay. Dusan. Welcome. Kristen. JP. JP. No. No, yeah, thank you. Anthony. I'll post the answer key later. And then you ask me a question. Okay, I want you to look at the answer key. And check your check if I total up right. Check if it matches your Moodle page. Let me know if something's wrong. All right. Don't just trust me. I'm a human. I make mistakes. Okay, last bit of the lecture today. Now, previously I gave you the function, right? The one I highlight in red there. So it's all right. Now, what if I don't give you the function? What if I ask you to construct it from the scratch? Well, here's the guideline. First, you assign a letter to each variable mentioned. And second, you find an expression to the quantity solved. And third, use condition given the problem to write the quantity solved. Now, what does that mean? I'm gonna jump straight to the problem because I hate reading those. Like, what does that mean? Okay, so let's do this one. This one pretty practical. Maybe I don't know if you was maybe sometime your dad asked you to do something in the garden. They set up a little garden for your mom or whatnot. Patricia wishes to have a rectangular garden in her backyard. She has 80 feet of fencing. So I'm gonna draw her garden. Sure, it's prettier than that, but in general, it's a rectangular shape. She has 80 feet of fencing. What does that mean? What's 80 feet represent? You should be able to understand what each number means. What's 80 feet represent? Yeah, the surrounding, right? The perimeter, right? That's 80 feet. Let me highlight that thing here. The perimeter. So all the side add up to 80 feet. Let X denote the width of the garden. So X will be the width of the rectangle right here. Then I'm going to denote this is the Y. And of course, this is X, this is Y, right? Find the function F in the variable X given the area of the garden. Let me highlight in blue. So what I'm looking for, I want a function F in terms of X. Remember F in terms of X. Just X. Inside F, just X value. I don't want no Y, no other letters, right? Okay, so given the area, so F of X is the area. Can someone tell me what's the area of the rectangle? Rectangle. Yeah, rectangle. Just based on that picture, what's the area? By the way, f of x is the area. Yeah, width times length, right? Or x times y. But the thing is, I want my f is in terms of x. I got y in it. I'm not happy. So I need to replace, I need to substitute y with something else. With something with x. Right? How do I do that? Or using what you have, how do I do that? How do I do that? I need to change y in terms of x, some function of x. Using the parameter information. Do you agree with me that all of the edit equals 80? Right, which is the perimeter, right? The perimeter is 2x plus 2y equal to 80. It's perimeter rectangular. Can I solve for y? Subtract 2x, right? So 2y equal 80 minus 2x. Divide everybody by 2. So y equal 40 minus x. And what you do is you plug it back in there. So now you have what? X times 40 minus x here for y. Distribute the x. 40x minus x squared. And that'll be your f of x. You're done. That's all they ask. That's all they ask. That's the first part. Now the second part is, what is the domain of f? Now, you can tell me, maybe this is a polynomial function. The domain should be what? All real numbers, right? It's true, it's true. But remember, this is application. So in real life, not everything follow a pure mathematical model. So pure math say domain is everything. But in applied math, say you need to restrict the domain that in such a way that make your problem make sense. Right? So for example, I cannot have negative length. Right? So in order to find out what is my domain, I'll use green here. I'm going to see if I can factor that function. So f of x equal, let me rewrite it here, 4x minus x, 40x, sorry, nobody's telling me I'm missing an x there. 40x minus x squared. Factor out an x. I got 40 minus x. Okay, so first of all, if I set this equal to 0, just to see what happened. So either x equals 0 or x equal what? 40, right? So the two numbers that I see now. In terms of it just common sense, you tell me the Patricia's garden. Well, can I have a negative length? Remember, x can't, right? So x is either what greater or equal to 0. Usually you're not going to include 0, but it's just right out there. Or less than or equal to what? 40, right? Because she only have a certain amount of fencing, right? It's not infinite. So that's the domain. That's the restriction. Right? For the restriction, it's likely you have to think like in common sense. But first of all, you need to find the critical values. What are the critical values? Critical values when you set the function equals 0. Like that's, and you restrict them in between. Does that make sense? If you don't believe me, you can pick something that larger than 40, let's say 45, and plug it in here, see what happened. I just want to see what happened. 45. I use 45. Here, back P for Patricia. What is it? 40x minus x squared. Yeah, 45. See what happened? You have a negative area, right? You cannot have negative area because remember, what's f of x represent your area, right? Yay, 34 work because between 0 and 40, right? This positive area. So you okay. All right. Last one, and then I'll let you go. This one a little bit slightly harder. So I'm gonna walk over with you. Charter flight revenue. If exactly 200 people sign up for a charter flight, they charge $300 per person. So let me write that down. So this is scrapbook right here. If exactly 200 people, they're gonna charge you $300. Then you know how much they make, right? 200 times 300 is 60,000. So they make 60,000 in revenue. Now, hypothetically, if more than 200 people sign up for the flight, then the fare is reduced by $1 for each additional person. What does that mean? Yeah. So yeah, in that sense. So say if I have 201 person, then what do I charge for the 201 person? 299, right? So 300 minus 1. If I have 202 person, then how much I charge for the second extra person? 298, right? And etc. Right? 203 person, they charge 297. If I call X is the extra people, then what happened? 200 plus X, right? X is the number of people, extra people. If you notice that 1, 1, 2, 2, 3, 3, so X. So 300 minus X. You're done. Then, so let me write nicely. So let X be the number of passenger beyond 200. Right there. They actually do it for you already. They kind of define the variable for you. And by logic right there, you did on the scrap work. F of X equal 200 plus X times 300 minus X. And it makes sense. If I plug in 0 here, right? It makes sense, right? No extra passenger. Don't stop it here. Just FOIL it. 200 times 300 is 60,000. Negative 200x, positive 300x, so positive 100x minus x squared. And your last bit, the domain. Can someone tell me what's the domain? First of all, if I call X is extra people, then X has to be at least what? Yeah, at least 0. At least 0. So I know the X is has to be greater or equal to 0, but less than what? Let me write like this. You cannot have negative passenger. But less than what? Less than what? Less than. Which one? 200 or 300? Let's see. Let's see. If you doubt yourself, you solve it. If you set it equal to 0, what happened? X equal negative 200 and X equal 300. So which one you pick? And why? Oh, move the, which one you pick? Yeah, because you can have negative passenger, remember? Yeah. So it's logic. It's all logic and common sense. All. So no. Done. I'll post it on the Moodle. That's it. Perfect timing. If nothing else, have a good one.